Hello and welcome back to the Answer Me channel. Today we're looking at quadratics. So what are quadratics all about? So we're going to be looking at the standard form, the turning point form, what a quadratic looks like when it's graphed, what its factors are, and how we can use the quadratic formula to help solve quadratics. Now, if you haven't gone and watched my other YouTube videos on algebra, please do. They'll give you a wonderful introduction to come back to when you come do quadratics. So let's begin. So the quadratic standard formula is this one. So ax squared plus bx plus c. So what defines a quadratic is the fact that it has a square root. Has a square root. So this means that you're going to get a different kind of line to a straight line, which has the formula y equals mx plus c. But you can go have a look at that on my other YouTube video, which is about the difference between different types of lines and their equations. But a quadratic equation has the square root. So when it's graphed on a Cartesian plane, it's going to look something like this. You've probably seen these. So these have the general formula ax squared plus bx plus c. Now, we're going to look at each of these terms together. So, what does the a tell us? So, for the a, we're looking at two things, where its sign and its size. So, depending upon whether the sign is positive or negative, it'll tell us which way the curve is pointing. So if the curve is positive, it's in an upward direction, like a smiley face. If the curve is negative, so if A is negative, it goes downwards, a negative direction. Or as we like to call it, negative concavity. And positive concavity. Okay, so if A is positive, it's concave up. If A is negative, it's concave down. Great. Then we look at the size. So what does the size tell us? So the larger the number, the steeper the angle. So that is to say, if this becomes larger, so if A is a large number, this is going to be much steeper than if A was a smaller number. So if it was smaller, it would look wider like this. But regardless of A, signs, regardless of the size of A, the sign will determine whether it's up or down. Now, what does B mean? So, B on A, so when everything is divided by A, is equal to root 1 plus root 2. So we studied in the last video that roots lay across the x-axis when the line crosses it. So a quadratic crosses the line in two places, and we'll study the situation which it does that. So it crosses the line. If it crosses it in two places, it has two roots. So root 1 and root 2. So b on a is equal to root 1 plus root 2. Now, a similar thing happens with c. So c on a is equal to root 1 times root 2. So root 1 times root 2 is equal to c on a. Now, if you go and look for the factorizing video, you'll understand how we can use these to factorize quadratics. And we'll move on to the quadratic formula now. On to A. So this is the quadratic formula. So there is one potentially foreign element that you might not have seen, the plus minus sign. So what that means is this is going to be minus b plus square root b squared minus 4ac on 2a, or and slash or minus b minus square root of b squared minus 4ac on 2a. So this plus minus sign means either this or this, and or. So we need to calculate for both. So with the standard form ax squared plus bx plus c, we need to incorporate that into 1 to find root 1. We need to incorporate it into this to find root 2. And then the product of these will equal c on a, and the sum of these will equal b on a. Okay, now there is one special part of this that we should focus on in more detail, and it's called the discriminant. Okay, so this is called the discriminant. What it is it tells us how many roots we are going to have. So if b squared minus 4ac is less than 0, no roots. Why is this? Because the square root of a negative number doesn't exist. So if we move this to a new page, what this means is if we were to graph it, the line might look something like this. So it doesn't actually pass the x-axis. So it's above it. And what this means is it has no roots. And the same is for something like this. It has no roots. Okay, but we have a couple other options. What if b squared minus 4ac, which is the part from inside, what if that is equal to 0? Well, what that means is we're going to have exactly one root. Let me erase this. We're going to have exactly one root. So when we draw it, it might look exactly like this because it touches the x-axis in one point. So in reality, what this will look like is x plus a, x plus a. So it'll be the same root in both times. So it's a repeated root is what we say. So when b squared minus 4ac equals 0, we only have one value for our roots. So another way of thinking about it is b squared minus 4ac equals 0. It means it's a square. So a plus b squared, we can write it in the form a plus b squared. Great. But what if b squared minus 4ac is larger than 0? This means we were going to have two roots. So one root and no roots. So when b squared minus 4ac is larger than 0, we have two roots. What does this look like? Well, if we draw it out, what we're going to get is something that passes the x-axis twice. So our root will be there and our root will be there. We'll have two roots. And that's when b squared minus 4ac is larger than 0. So there's one final thing we need to look at, and that is turning point form. So if you go and watch the factorizing video, you'll look more at how to figure out the turning point form. But I will show it to you now, and then you can go on to the factorizing video, and there you'll be able to see how to solve for the turning point form. But it looks like this: ax plus x minus b squared plus k. So the value of k is going to be our y value the value of k is going to be our y value in the vertex. So what is the vertex? On this graph here, the vertex represents the turning point. Thus, it's called turning point form. Turning point form. So, the k value is the y value in the vertex. Then, whatever value of x makes this 0, so in this case it would be b, whatever value of x makes this 0 is going to be the x-coordinate. Okay, so let's recap. We looked at the discriminant. If there are no roots, we know that the discriminant is less than 0. If there is one root, we know b squared minus 4ac is equal to 0. And if there are two roots, we know that b squared minus 4ac is larger than 0. Furthermore, we looked at the turning point form, and we know that whatever value of x makes this 0 is our x-coordinate for the turning point, and whatever value of k we have at the end is our y value. So what did we look at today? We looked at the standard form, we looked at the turning point form, we looked at the quadratic formula, we looked at what a, b, and c do in the standard form, we looked at the discriminant, and at roots and concavity. I hope this has helped. Stick around for the next video where I'll be looking at factorizing. Don't forget to go to the Answer Me website and vote for next week's series of lessons. See you then.